Hi, everybody, from wherever you are in the world. My name is Salil Amonkar. I'm the Global Head for Manufacturing and Artificial Intelligence Machine Learning Practice at Pluto 7. Pluto 7 was named the Global Breakthrough Partner of the Year by Google at Next 2018 in July. We focus on manufacturing, retail, high-tech, and healthcare industries. So without further ado, let's look at how predictive maintenance and preventive monitoring is achieved using machine learning and artificial intelligence. Just one more point before I get into the meat of the presentation. Feel free to ask the questions. I'll keep some minutes towards the end of my presentation to go over the questions from the audience. So with that, let's go forward. So I've been involved in basically implementing a bunch of solutions with multiple technologies throughout my life, focused on the manufacturing, high-tech industry. The questions that keep coming up are, with all the technology advances, how do I ensure that I have productivity in my manufacturing operations, which can roughly be translated into the following. Are my machines running efficiently? How do I know when they're going to break? I'm forced to do preventive maintenance on schedule, ensuring that I never have downtime. But am I doing it at where I'm having the utilization of the machines to the maximum without having to deal with breakdowns? How will I ramp up my production volume without getting into issues and overworking my machines? Will my machine and my labor work together well? These are typically the questions that come up. So now let's look at what this means in terms of machine learning and artificial intelligence. So really, if we think about how human decision goes today, a lot of us, we make decisions, and in the process, we introduce our bias. Even with all the technology advances, if you go and look at the automation that has been done today, a lot of that is based on rules. At the end of the day, those could be statistical rules, or those could be rules that are done by experts. In the process, invariably, we introduce bias. The key advantage of leveraging machine learning and artificial intelligence is it avoids incorporating the bias in its decision making. And the best option that in a utopian world that really works very well is having machines and human beings coexist, where machines are making the decision and helping the human being. This is no longer now the realm of science fiction. It is, as you will see in the example that I'm going to showcase to you, it is very possible. It's doable. You must have heard about it. If you're already using machine learning and AI, if you are thinking about using machine learning and AI and wanting to learn, you will see that in my presentation, that you will get a flavor for how one can go about it, and then you can start embarking on your machine learning and AI journey. So what are the areas where pretty much focusing on predictive and preventive maintenance monitoring that stand out, where machine learning can do better? Well, based on what we have seen and what we have observed as successful utilization of machine learning in the preventive maintenance and predictive areas, is detection of anomalies in data. That's one of the very good use cases. And then leveraging that to prevent downtime is also a good option, where it's not just, and you will see in my presentation going forward, that not only can you prevent downtime, you can also work the factors that are the inputs into your processes to actually increase your time that is between a start or a stop. So you can actually improve your production productivity in that way. Another option is to really use machine learning to help improve the quality of your finished goods, where you can enhance if you have already automated processes, you can enhance them, or if you are using labor, you can actually have better quality control using machine learning-based solutions. So at this time, I want to showcase to you an example where one of our customers used machine learning to basically help not only have a better control over the start and stop of the production cycle, but also actually use it to help enhance their production throughput. So I'm going to share a screen so that you guys, a video that you can that will quickly showcase what was done. And this video actually was presented at the at the Gartner supply chain forum that I attended in Miami last week, because it was one of the top 6 finalists for the supply chain award for innovation and ROI.
Brewing is such an old industry, and we've used a...
Let me start again.
ABinBev is one of the largest brewing companies in the entire world. Key brands that we produce are Budweiser, Bud Light, and Stella Artois. Brewing is such an old industry, and we've used a lot of the same technologies in the last 100 years. And so we've started to use technology to digitally transform operations.
Our innovation team at ABinBev teams up with Google and Pluto 7 to find a way to extend the life of each cake filter process, which is a process where beer has certain particles that come from fermentation. You have these filters that are set up in which the beer turbidity level, which is how clear the beer is, has to get below a certain threshold. So what you have is a multivariable problem where when you reach a certain threshold, the machine has to be shut down. It's a balancing act because you have to keep that turbidity level below the required amount for that brand.
The cake filter process is a very manual process. What we've done is take a lot of the human error out of it and automate and really accelerate the decision making.
The solution was to take this Google machine learning engine, put in billions of simulations, look for trends within that data, or this can prolong the life here or there. Not only does it allow you longer average runs, but there's energy savings. And finally, there's the beer itself, which more uptime means you can produce well and not having to run.
The value of working in the partnership with Pluto 7 is that in a scalable state on the Google Cloud platform. The learnings we get from Newark we can scale across breweries across 126 countries. Artificial intelligence Pluto 7 and Google Cloud platform is part of this broader vision to transform how we make beer, deliver it faster, more consistently, higher quality to our valued customers.
Every opportunity we have to be at the forefront puts us in a position to compete better, but also prove that technology like this can be successful in an industrial environment.
Okay, so I hope that was pretty informative. So now let's go on. I'll go through how did we go about taking what you just saw and implementing this solution at this particular customer. I'm going to share information that was already publicly shared, so it's okay going forward. So before we go into the actual solution, I just want to explain how does machine learning come into play and how is it that it provides more value than your traditional automation that most of you are used to seeing in the manufacturing and operation world. So a lot of time, whether it is automated systems already in place, deciding whether the machinery is faulty or not, whether you do it manually or even through your controls in place, it's essentially based on human rules. Either those rules have been implemented in the automation or somebody at a production or a supervisor is making that determination. So that's typically what happens most of the time. In doing so, we are only looking at certain elements of the data that as an expert, if I'm a production expert or if I'm a distribution expert in the warehouse, I sort of have my understanding that, okay, if I look at these particular indicators, that should be good enough. And that's what typically we do, or we implement those that knowledge in the rules that we implement for automation. Where the opportunity for machine learning comes is looking at data that perhaps we should be looking at that we are not looking at. So in the production process, we actually typically end up in collecting a whole bunch of variables. Some of it, which you are seeing in green, are the ones that we always look at. But there are those in red that we are not looking at, which a data or a machine learning algorithm, for machine learning algorithm does not come with any bias. It's going to look at all the data that you will feed it. So it's looking at all this information, and it looks at patterns that perhaps as a human we are not looking at. And so in that process, it's using that to make decisions on what your target output should be, which is the decision on if it's a part within an equipment, okay, when will that part fail? What is the usage? And all of those points or data points is what the machine learning algorithm of the brain is going to use to make the right decision going forward. And it will keep learning. It will keep adjusting based on the data. So if your machine is running slower versus if your machine is running faster, it automatically uses that information in making its prediction, which is the fundamental difference between how machine learning works versus typical traditional linear programming or pure statistical based models. So the key towards machine learning is, of course, data. You have to have data. The beauty of a manufacturing process is data is always collected in a typical manufacturing process, whether it is using legacy inputs or now with IoT, you can have even more advanced sensors in there. Bottom line is there's a lot of data that can be collected about the processes that can then be used in a machine learning algorithm to basically go forward with the desired result. So essentially, the data that typically will be neglected by a human being is now being processed by a machine that can then actually go through and process it and give the right results. Now, you may ask, well, what does it take for us to implement something like this, and how do we go about doing a machine learning project? What we have observed based on our experience is, and let me pause here because I'm seeing a lot of questions. Let me go to support, and the people saying that you are not able to see the presentation and that you are not able to see the video. Let me call support and find out if people are able to see the presentation or not. Okay, I've reached out to support, but if you guys are able to see the presentation and hear me, I'll continue. So while we are fixing the presentation, I just want to talk about what I just said. So the question is, if I want to do a machine learning project, how do I go about it? How do I figure out what is the right use case and so that I'm set up for success? What we have seen based on the work that we have done with customers is that the best way is to have somebody like us come and work with you, help you identify the use cases. We do the qualification of the use cases that are of importance to you, and identify the right use case, which involves facts like, do you have the data that will support that use case? Is this use case suitable for machine learning? Once we help come to a decision on potentially which use case it is, maybe within preventive maintenance or quality control, that will be a good use case to go forward with. Then typically we have seen that it takes just 4 to 6 weeks to do a proof of concept that will help build a prototype model, which will showcase the result so that you get the confidence that, okay, machine learning really is something that I can use. I'm familiar with it. I get familiar with it. I can see the results, and I can take it forward. So, for example, in that particular video that I shared, it took us basically from start to finish about 6 weeks to show the value of how we could predict at what point of time that beer filter would fail. So, and we did that with at the end of the 5th or 6th week with about 92% accuracy. Okay, tech support just assured me that there's nothing wrong. So I apologize if some of you are not able to see the screens, but they are assuring me that you're able to see the screen. So for those of you who are able to follow my presentation, great. And again, my apologies if some of you are not able to follow it. So as you can see, the machine learning project is not something that's going to take a whole bunch of time for once you make a decision to go about doing a proof of concept from the time you do start to the time you finish. The beauty of this is, for example, if you're not able to figure out how do I justify going about a machine learning or an artificial intelligence project, one way to do this is do a proof of concept that will help show you the result. You can use the result to then build an ROI. This is exactly what happened with ABinBev. Once we showcase to them that the model will work to help with their beer filter prediction, then we help them come up with the ROI that, okay, if we implement it on number of so many lines, per line, this would be a saving over a year, and then that will result in so many millions of dollars of saving over multiple lines in a particular region over a year. So this helps in justify the ROI against and some of these innovative technologies such as machine learning and AI. So I wanted to spend a little bit of time around this so that everybody gets to see that this is something that's pretty doable. For those of you who are already working, I'm sure this was something you already were aware of. So the critical success after you do the POC, and in fact, something that you want to plan for as a part of your POC is, remember, it's all about not just about technology. It's more about taking the technology, taking those learnings, and then adapting it for further usage. So whether it is machine learning, AI, cloud computing, the other factors to consider are people, processes. So big factor is making sure that you have identified all the stakeholders that need to be part of this, not only during POC, but assuming after proof of concept that you're going to deploy this, especially in a manufacturing environment. You have to think about various plants, various lines, your different people, the kind of reactions you might have. So all of that stakeholder alignment has to be taken care of. You need to make sure that you have the right data, so that the data, without data, machine learning cannot work. So because it has to learn from the data to make sure that when you're deploying across multiple, once you've done the pilot that you're deploying in various lines, your understanding of what data is available, not available, becomes quite critical. So let's take a deeper look into how, in this case, we achieved the 92% accuracy. What were the key factors? How did we go about taking something that has been done for centuries, such as a beer brewing, and then use AI and machine learning to not only do quality control, but basically improve the taste of the beer as well as improve production. So the key problem here is the filter is critical towards producing a beer that has the right amount of consistency and right amount of taste. And for the people who drink beer, you guys get it, that the different types of beer has different consistencies in terms of color, taste, which is based on some of the, not only the material that's used, but also how it is filtered. So filtration is very, very important process. And then the way the filtration works is it's almost not exact science. It's part art and part science. If you do not pay attention, if you take the filtration off early, then you are losing the ability to get more throughput from the filter. If you wait too long, you end up in getting a beer output that may not meet the quality, and you might have to scrap it. So it's really a art problem where a brewmaster would make the decision on when a filter will have to be replaced. So that's where machine learning came in, and we felt this was a very good use case because there was a lot of data available, and also we could use that data to really help make the right decision on predicting when the filter would fail. And not only, as you will see, did we do that, but we also helped figure out how do you, once you predict when the filter will fail, you can now also tweak some of the key inputs that will help prolong the life of the filter, therefore saving the company more money. So how does the machine learning model work? Well, literally, if you think about how, as I said in the beginning piece, machine learning and AI is nothing but a replication of the human decision making, except that it is human decision making at scale. If any, as human beings, there are two types of decisions that we make. One is we say if something is either good or bad, right or wrong, cat or a dog, which we call as classification. You'll hear these words in machine learning and AI terminology. Or we make decisions that based on our past experience, this we think is going to happen in the future. So examples, what we call as forecasting, when this particular event will happen. Okay, we have observed that over the past, the machine has pretty much operated this way, therefore in the future, over this much period of time, it will operate. So that's what is called in machine learning as time series. So what we have, how does our model work is essentially it combines two things. It looks at the data, and at the end of the day, it has to do a lot of what-if scenarios, analyzes about 50 plus variables. What is the target output? The target output is making sure that the beer has been produced with the right quality, which in terms of actual measurable term is optimizing turbidity. What they do is look at the turbidity of the beer. Now, there's another factor. As the filtration process is going on, part of the reason why the filter will have to be stopped is either the turbidity has increased or there's too much pressure that gets built up in the filter. So it has, either of this happens, you will get a filter where you have to replace it. So what is the model going to do is figuring out with all the input that is going on, that it learns, okay, what is the maximum point to which I can operate this filter so that I can maintain the turbidity at the right level, and I make sure that the pressure is not going to go beyond the threshold. Therefore, I keep the filter operating, and then at the time when I know that it can no longer function, I will make the recommendation that we should put a replacement in place. But at that point of time, what we have achieved is maximize the length of the time the filter has been in operation, and also therefore make sure that it's been operating with the right quality of beer that is produced. So this gives an architecture of the solution. So I'll try to keep it simple. At the end of the day, we want to make sure that we keep getting inputs. So that's what you see in the source. There's an input coming in that's coming in from all the parameters that have been measured on the production line and captured with the manufacturing execution system. All of these systems are already in place with most of the companies that are in operation. So we capture all of that information, we put it on the Google Cloud platform, we put it in something like a BigQuery, which is like a data warehousing on the cloud. It then feeds our machine learning model, which is we use TensorFlow. That's an open source model. The beauty is using a Google Cloud platform, all of this is running at tremendous scale and speed, so that as the inputs are coming in and we take samples at 5-second intervals, and then the machine keeps learning, it looks at it, and it produces a recommendation on whether what has to be controlled so that we can make sure that the production run is better. So in this situation, we observed that actually we needed to give the recommendation over every day, so we didn't need a real-time recommendation. So in this case, we just made a prediction call from the machine and gave it to the controller to just let them know whether they needed to adjust anything as a first phase. There is a discussion going on to make sure that we put this as a fully automated output call, where it would then feed directly the control systems. But this was good enough, and as you'll see what the results will look like shortly. So this is the general architecture. Typically, most of the machine learning solutions that are based on Google Cloud Platform, you'll see some variation of this architecture. At the end of the day, there's input of data, there's processing of data using data flow. Data lab is nothing but like an IPython notebook that machine learning expert will use to develop the machine learning model. And then it gets deployed onto Google Cloud Machine Learning Engine. The predictions are made, and those then get either connected to the control systems or they give recommendation to the controller. So what I want to share a few of the things that our model helped the production guys at the customer find out. So after we put this in operation for about 6 weeks, we figured out that there were 3 best practices that the machine learning model recommended, which was not very intuitive. And this is the value that you'll see, which was actually contrary to what the experts really thought they were doing. One is, it gave a recommendation that in order to prolong the life of the filter, it is better to increase the rate at which the body feed had to be fed. And this was not very intuitive because the thought process with the production folks was, in order for me to save the expensive material, which is the body feed, I would rather start slow and not increase it. But in the end, what happened is when they did that, it resulted in actually the shorter runs of the filter. As you can see, these dots, which are on the x-axis. The x-axis represents the length of the runs. And if you see the dots that are in the first few instances, the first 6-7 instances, that represent the short runs. And you will see that the rate of the body feed there is way low, versus when they started using higher rates of body feed, then, which is designated on the y-axis, you will see that the runs started becoming more and more. So this was one of the best practice that was counterintuitive to what the production folks were always used to seeing. And I want to mention this because this is an excellent example of how a machine learning model finds things that are not intuitive to even to the experts. The second one, best practice that came out of using machine learning model was that, okay, it helped them figure out if there were any fluctuations, which was being monitored by the model. And it proved that by avoiding fluctuations in the first 1 hour of operation, they also helped ensure that the beer filtration operated within a longer time and produced more beer. And finally, a third one that came out of all of this was that keeping the body feed rate about 30 all the time as much as possible would also avoid shorter runs. So most of these were, again, not something that was obvious to the experts that did this for a living. After we implemented this, pretty much the production people over there said, this is really good. We could not even have figured this out with what we had. And another interesting thing I wanted to share with you guys is, one day after we while we had implemented this model, I saw from the data that actually the body feed had gone to below 30 in one of the lines. And I casually mentioned to the production guy, I think you will see a shorter run, and let me know if you do that. And when the guy came back and said, Salil, how did you figure out that there would be a short run? I said, well, I was looking at the data, and I saw that you guys didn't maintain the body feed as we had recommended. So that's how I knew you will end up with a shorter run. The point is, because of machine learning and because of the model that we use, we could let them know proactively what would happen, right? And this is an example of how preventive maintenance, if you think about what I just said, and this is something that this company is now looking at expanding as well as using as better control capability. And we are planning to use the same method in other areas of production. But this is an excellent example of how you would let a machine figure things out for itself and then use that information to improve its own performance. So at the end of the day, these were the results from this production pilot. We put the model on 2 of the brewery lines in Newark. And we saw that there was a 44 to 80% improvement, not only in the time between the start and stop of the filter, but also the amount of beer that was produced, which was very significant. And now, with the success of this, there is already an agreement that we will be deploying the same solution across multiple beer lines in this company. So, where does this leave us? I gave you guys an example of how machine learning and AI can help really have machines learn and use that learning to improve their own life. Now, this already has been proven in the case of this customer. They are now strategically thinking about using this preventive maintenance capability, deploying it, and coming up with what is called as what they are calling as preventive maintenance platform of the future. And from this point on, you can actually, which is where I want to show, where does this lead? Well, this actually leads to essentially the next generation capability of what we are calling as factory of the future. You might have heard about this term, or manufacturing 4.0, as you will see next. So I'm going to skip this. I already just showed you the architecture, but the point here is in terms of Google Cloud Platform, or for that matter, any other cloud platform, we are very focused on Google. So I'm showing the Google platform where all of the things that you need to talk about need from an artificial intelligence or machine learning solution, all the components that you need are there. And so it's a question of using them. You don't need all of them, but in most of the situations, the ones that are required most of the time are BigQuery. Some of the top ones represent pre-built models, which any one of you can use. You don't need a machine learning or a data scientist to use these. For example, Vision, you can use that for simple quality control by looking at images of, let's say, your packaging, and then figuring it out whether you have packaging defects, etc., to TensorFlow, which I already explained is like a custom model like the one we built for the customer that you can use. We have all the components for capturing data and also for making sure that you have not only the data capture, but then processing the data at scale, including IoT capturing IoT data, managing it, because that's a large amount of information that has to be managed at scale. All of these are the components that are available. So taking it now that you can see where machine learning can be used for preventive maintenance, it helps you make sure that you can improve your quality at lower cost. You can do preemptive maintenance of your production line, and then which results in ensuring that you are meeting your customer demand. But then I want to, before I go to the Q&A, set the stage for example, what does this really mean, which is what I was introducing in the discussion prior to the architecture, which is your next generation manufacturing. Like I said, one of the customers is already thinking about looking at what they're calling as the brewery of the future. Well, if you look at manufacturing, next generation manufacturing, you'll hear some of you might have heard about this, but I don't assume everybody is aware of this. So you'll hear the term manufacturing 4.0. Well, what is manufacturing 4.0? If you really think about it, it's the next generation wave of the next generation of manufacturing that is now possible with all the advances in AI, machine learning, IoT, and then cyber physical systems. So 1.0 was the manufacturing revolution that was powered by the steam engine and electricity. Then, steam engine and water usage, and all the mechanization that went with it. The second was the one that was powered by usage of electricity, and then with the concept of assembly line, especially with the car manufacturing and Henry Ford. The third happened in the late 70s, 80s, now with computers coming in and the linear programming that was used for driving automation. And now we are on the cusp of what we are calling as the next generation for manufacturing 4.0, where combination of artificial intelligence and machine learning, along with IoT and cyber physical systems, is now, which means robotics, etc., all coming together now to really have a factory of the future. So what I shared with you can slowly be used to build together the intelligent supply chain and next-gen manufacturing. And this is a visual depiction of that. And more importantly, how do you go about step-by-step building a roadmap to that? So with preventive maintenance, think about that as a building block. Then you can use that to say, I'm now going to build a preventive maintenance platform. You take that further and you add augmented analytics, autonomous things, and now you're actually going to create, like you'll hear all these buzzwords like digital twin. Well, what it is, digital twin is nothing but a complete automation of how you do a process that may be part man, part machine. Digital thread is nothing but threading all the data together, where with cloud computing, all of that, getting a 360 view and using that data then to drive machine learning based solutions or analytical solutions. All of this become the foundational elements that leads into more and more automation, where you start connecting your plans together. That's where, as you go up this chain, you're now becoming more and more strategic. You have productivity, and then if you think about all of this being put together, now you have a smart supply chain where you can have new capabilities that are not even in existence today. And a very example of this is, I heard, and I'm trying to figure out who has done this. When I was at the Gartner conference, one of the Gartner analysts told me that somebody had created a factory in a box. What is that? Is they actually put a complete production line inside a mobile container, and they could actually have that production line operating wherever that container was sitting. Now, how that is possible is because of the fact that we no longer have a complete dependency on a wire-to-wire access. With IoT, you can think about connectivity through internet, and with some of the high-speed connectivity coming up with what they're calling as the 5G, all of this is becoming more and more real. So now factory in a box, I mean, that is provides a lot of other kind of capabilities that are not even being thought of today, as an example. So with the point is, I wanted everybody to get a view that not only do you start using AI and machine learning to start showcasing and doing proof of concept, but then using it to start developing how you can take this small baby step, look at your strategy to go and look at finally something that is like a supply chain of the future. And all of this is really possible. A few out of the leading edge customers are already thinking about this. I was at the Gartner event last week, and there I heard people, there was a topic on 4.0. So it's not like people are still saying, okay, how do we do it? There are companies who are already thinking about laying down the groundwork and the strategy for their next-gen manufacturing. So I just wanted to give that final thought, and with that, I will now go and see what are the questions that came up and try to answer all of them one by one. Okay, so the first question that I have is, what industries do you believe the AI and deep learning will replace the current situations? What sectors, i.e. occupations and jobs, will be replaced first at this wave of digital industrial revolution? This is an excellent question, and this question did come up in the conference that I attended as well. So based on what I have seen and what I'm seeing and what I'm hearing from some of the industry leaders, first of all, the one area that I see AI and machine learning in the manufacturing space, I see a lot of opportunity in terms of industries, a lot of opportunity in healthcare, in retail, and in manufacturing for sure, as the advances are able to provide with deep, what you can say, innovative capabilities that drive breakthrough business benefits, right? So definitely those are the industries. What has to be thought through, the second part of the question was, what kind of change is it going to entail? Well, I can tell you the key thing that's on the top of the mind is really the change management. It's about upskilling your workforce, right? I mean, when you're talking about the kind of solutions I just demonstrated, you don't know, you might have to start thinking about, well, the person who was monitoring the filter, rather than monitoring the filter now, maybe they should be doing looking at the entire production, and they need to be skilled enough to understand what is the machine recommended and how do I act on it. A simple question that came up was from one of the manufacturing leaders, hey, my team are paper pushers on the shop floor. They know only how to take a paper and follow instructions. Now they'll have to look at charts. They might have to look at some control panels and then take action. So those are the kind of things that you have to think about. Okay, let's go to the next question. I believe the session is recorded. I'll work with the agency, and I'll make sure that if it is being recorded, that it is available for you to look at later. Another question, for a predictive or forecast result, this is a probabilistic result. So how is the statistical spread displayed as a part of the result, i.e. a bell curve? I think just to reiterate, the machine learning model gives a recommendation. Remember, I said it's actually a thinking. It's a brain on a chip. We are not like going to give a statistical result. It will actually, based on the target result, it will tell you what has to be done. So in the example that I gave, it was a precise result, and I gave that through best practices, which is, hey, make sure that your body feed is being fed at a certain rate. It's not a bell curve. It's like, yeah, this is the rate that you want to make sure your body feed is being fed at. And or in another best practice, it was keep it, make sure that it doesn't fall between a certain level. So with machine learning, you can get more precise than a typical statistical spread or a statistical process control. So that's the answer. Were there any third-party tools used to help with the machine learning? The only thing here, this is another question that I think I try to emphasize it. In this particular solution, we use Google Cloud Platform and everything that was available on Google Cloud Platform. Now, I did mention that we use TensorFlow, and I'm sure not everybody knows it, but TensorFlow is open source. We didn't use any third-party tool. Everything that we developed was using Google Cloud Platform and the components on Google Cloud Platform. Let's see what other questions are here. Okay, then there was some issue. Some people were not able to use it or see it. Okay, let's see if there are any other questions. I think that's all the questions that came up. I'm going to leave this open for another 5 minutes. If there are any more questions, please go ahead and ask them. Otherwise, in the next 5 minutes, we'll close this webinar. Okay, I don't see any new questions coming up. Okay, with that, I think I'll leave it open for 1 more minute max, and then we'll close this webinar. So for everybody who has attended, thank you for attending. Once again, this is Salil Amonkar. You see my coordinates. Happy to get questions from you and happy to answer them. I hope this was very useful. And please give me the feedback, good or bad. I want to get the feedback so we can make this session better for future presentations. I'd like to really thank everybody. I hope that it was at a decent time. There are 135 attendees. I don't get to see where you guys are from, so I hope it was at a decent time for all of you. Personally, I'm based on the US West Coast, so it's about somewhere late afternoon over here. Okay, with that, I don't see any more questions. So with that, we are now closing the webinar. Thank you very much, and have a good rest of the day. If it's day for you, or if it's early morning, have a great morning, and if it's late night, have a good night. Bye.